this is a 1500 watt buck boost DC-DC, right? Input range 9 to 80, output range 9.6 to 60. But this is more for battery-powered applications. The cool feature of this is actually our pass-through capability. So we call it our programmable high-efficiency pass-through. What it does is we allow the customers to actually set, a low and a high end pass-through window, right? So that for as long as your battery voltage is within that range, the converter is really just passing that voltage to the output without any switching. What it does now is without the switching, you avoid switching losses, and it beefs up your usable power and then efficiency. So if your efficiency is higher, you're actually saving customers, number one, for optimizing their battery utilization. So for mobile applications that runs on battery, it's going to help the run times of the equipment much longer. So to demonstrate that pass-through capability, I have set here the kind of a setup here. This is the i9C module. Right now, this is set for a fully regulated unit, meaning to say it's not in pass-through mode, because the customer can program it whether in pass-through mode or in full buck boost mode, right? If the battery starts going down in voltage, you'll see that the output is maintained to 24 volts output.
That's the output.
That's the output, right? So you're regulating it to 24. But some applications, you don't need fully regulated 24 volts. Sometimes the load that is being powered up from the battery could be 20 volts to 28 volts, that window, right? So you don't need fully regulated solution. Now, so if I put a load here, and then let's say I'm powering up 24 to 24 with a continuous, conduction mode, meaning to say buck boost mode, your efficiency is about, 97%, right? Now, I'm gonna switch it, I'm gonna change the mode to pass-through mode. And that's the two resistors that are set in the system, right? With that capability, wherein you're just passing the input to the output, there's no switching action in the power conversion stage. You get a bump in efficiency of about, this is 98.4%, right? So how does the dissipation look like? That's about 2% improvement of your efficiency, and that's about 5% less dissipation. That's about a 53% improvement in your power dissipation, total power dissipation of the i9C, right?